Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at Lesson 3 from Chapter 5, which is talking about radical equations. So we're just going to jump straight into an example, which is number 2 from your notes. So here we're going to state the restrictions on the variable, and then we're going to solve the radical equation. So in order to state your restrictions, so here's step number 1, you have to ask yourself, can the variable be any number, or is there a value or maybe values that would make it either undefined or it just doesn't make sense? So let's look at this equation here. We have n minus the square root of 5 minus n is equal to -7. So here we need to look at where our variables are. So here in our first little bit, we have n is just out on its own. That one there can be any number. It's totally fine. It doesn't matter if it's positive, negative, fraction, or a decimal. N can be anything there. So one thing that'll be more specific is that when we're looking inside the square root symbol, when you're looking at a square root, the number inside the radical symbol, so the radicand, cannot be a negative number. It can be 0, it can be positive, it just can't be a negative number because then it's undefined. So what we have to do is we have to find out all of the values that would make this radicand 0 or negative. And in order to do that, we're going to find out where that value is going to be at 0, and then it can't be anything either to the left or right of that number. So our first step is to set that radicand equal to 0. So we have 5 minus n is equal to 0, and then we're going to solve for n. So you can start by getting rid of 5, so you could subtract 5 on each side. So you're left with negative n is equal to -5. Then we don't want negative n, so we're going to multiply it by -1 on each side. And what we find is that n would be equal to 5. So at this point here, n at 5 is going to make your radicand 0. So you want to ask yourself, well, what happens if n is maybe 6? So what happens if we go higher? What happens if we go lower? So say if n was 6, we go 5 minus 6. That would give you -1 as your answer. So we can't go higher than 5. But what happens if we go lower than 5? So what if we went 4? So we had 5 minus 4 is +1. This is good. We want this. So basically anything higher than 5, we don't want. That would be undefined in your radicals, under that radical. So in order to restrict it, we don't want anything higher than 5. So we're going to say that n must be less than or equal to 5. So it's basically saying that n can be 5, because then that would be 0, which is fine. And then it could be anything less than 5. So it could be 4, it could be 0, -1. All of those numbers there would keep that radicand 0 or greater, or as a positive number. So now step 2 is we are going to look at actually solving that equation. So we want to find out what value for n is going to make that equation true. So I'm just going to start by rewriting this. We have n minus the square root of 5 minus n is equal to -7. So in order to solve, what we're going to do is we're going to get this radicand or radical by itself. So what I'm going to do here is I want to get rid of n, so we're going to subtract n on each side. So here we're left with negative square root of 5 minus n, and that is equal to -7 minus n. I'm going to take this one step further. I want this to be just that radical symbol. So I'm going to get rid of this negative, so I'm going to multiply by -1. And I'm going to multiply this entire right side by -1 as well. So negative times a negative makes a positive, so we have square root of 5 minus n. That's equal to, when we distribute that -1, -7 times -1 becomes +7, and -n times -1 is +n. Then what we want to do is we want to get rid of this square root symbol. That is really gross. It's really hard to try and think of a number that would make that equation true, so we're going to get rid of it. And so in order to get rid of it, you have to do that opposite operation. So you're going to square each side. So you want to do that opposite operation. So if this is a square root, you want to square it. So the square cancels out your square roots. So you're left with 5 minus n. Then that's equal to 7 plus n squared. Now, this still here isn't good enough in order for us to solve. We still can't see an immediate answer. It's not easy to solve. But one thing that we can do, though, is that we can apply this definition of that exponent. So a square means that you multiply a number by itself. So here we're going to multiply 7 plus n by itself. So we have 5 minus n is equal to 7 plus n multiplied by itself. So in order to simplify this right-hand side here, we're going to use that technique called FOIL. You have two binomials multiplying by each other, so you're going to use FOIL. So you're going to multiply your first terms. So we have 5 minus n is equal to, so it's 7 times 7 is 49. Then you're going to multiply the outside, so 7 times n, which is 7n. Then you're going to do the inside numbers or inside terms, so n times 7, which is 7n, and then your last terms, which is n times n, which is n squared. Then what we're going to do from here is we're going to start collecting some like terms. So in terms of like terms, you got to make sure you have the same variable and the same exponent. So here we have 7n, and 7n are like terms. So we have 5 minus n is equal to, so we have 49, and 7 plus 7 is 14, so we have 14n plus n squared. So what we're going to do here next is I want this left side here to be equal to 0, so I'm going to move all this stuff on over. And if you guys can kind of see where we're going from here, we're actually going to try and set this up so we can factor it. So I want to make this left side here equal to 0. So I'm going to subtract 5. I'm also going to add n. So you're going to subtract 5 and add n. So on our left side, these cancel out, so we're left with just 0. So we have 49 minus 5 is 44. 14n plus n is 15n. And then we have just n squared. What I'm going to do next from here is I'm going to rewrite this so it's in standard form. So I want my highest exponent first, and then it goes in decreasing order. So here we have positive n squared, so just n squared. Then we have plus 15n. And this here is a positive 44, so we'll separate that with a plus sign. So from there, we are ready to start to factor. So in order to factor, we're going to use that product sum method. So we're going to look at the product of your a times c value. So 1 times 44 would give you 44. And you want a sum of that b value, which is positive 15. So you want to look for two numbers that multiply to 44 and have a sum of 15. So, and if you have some trouble, what you can do is write down the factors of 44. So you have 1 times 44, 2 times 22, 3 can't divide into 44, so then you have 4 times 11, and then 5 doesn't go into 44, 6 doesn't go into 44, and neither does 7, 8, 9, 10. And then we're back up to 11, so that means that we stop here. So here we have all the factors of 44. So then you want to look, you have a positive product, so either both have to be positive or both have to be negative. And here your sum is positive, so all of your numbers here are going to be positive. So it means if we were to add up these numbers, so change these two plus signs, one of those should add up to 15. So 1 plus 44 would give you 55, 2 plus 22 would give you 24, but 4 plus 11 would give you 15. So here are your two numbers. So therefore your numbers are 4 and 11. So what we're going to do is we're going to rewrite this middle term using 4 and 11. So we have 0 is equal to n squared. We're going to write plus 4n plus 11n, and then bring down this plus 44. Then our next step here is we're going to group together the first two terms and then the last two terms and see if we can pull out a common factor. So we have 0 is equal to, and between n squared and positive 4n has a n in common. So pull out an n and you're left with n plus 4. And then looking at our second little group here, we have 11n and positive 44. So you can pull out a positive 11. And all we're left with is n plus 4. You'll know you did your work right if these two brackets are exactly the same. Because then what we're going to do is we're going to pull out those two brackets, or pull out a common factor of n plus 4. So we're left with n plus 4. And when you remove those, you're left with n plus 11. And then from there, you can set each of those factors equal to 0 and solve for n. So your first factor here is 0 is equal to n plus 4. And then you can set the second one equal to 0, so you have 0 is equal to n plus 11. So here we're going to solve for n. So here we have n plus 4, so we want to get rid of this 4. So we're going to subtract 4 on each side. And what we're left with is negative 4 is equal to n. Looking at our second factor, here we have n plus 11, so we want to subtract 11. Move it to the other side. And what we're left with is negative 11 is equal to n. So one thing that's going to be really important, which is actually the next step in our notes. Unfortunately, we don't have time to actually do this in the video, but if you were to verify both of these answers, you would find that one of these are actually an extraneous root. So one thing that's going to be really important, even if I don't ask you to, you must always verify. Because what you would find if you were to verify, you would have negative 4 would check out, but negative 11 would not verify properly. You would find that if you were to verify that, you'd have negative 15 is equal to negative 7, and that is not equal, which makes this negative 11 an extraneous root. So unfortunately, we don't have time in this video to verify it, but if you guys have any questions, make sure to come ask me in class, whether it's about solving radical equations or verifying. Or you guys can also text me on Remind 101. So thank you guys so much for watching.